Hello everyone, very good morning one and all. Welcome to the most comprehensive preparation platform for all competitive exams, BYJU'S Exam Prep, and welcome to the BYJU'S Premier League. So all dear computer science champions, join the session quickly and mark your presence in this BYJU'S Premier League. Dear friends, we are going to have classes both on YouTube followed by app, and in this session we will learn and also practice a topic from computer networks, very important topic, very most occurring question in the GATE exam, and that topic is what? Hamming code. So guys, through this BYJU'S Premier League YouTube plus app series for GATE 2024 aspirants, you may become master in error control and also master in computer networks. So today we are going to discuss the topic hamming code. Dear friends, today itself we will be learning it and also practicing it so that we can become perfect in this topic, hamming code. So why late? Join the session quickly and also share this session information to your friends over Telegram, Facebook, Instagram, Twitter, WhatsApp, everywhere, wherever you are connected. Alright, so let me start the session with quick introduction of mine. I am Satya, research scholar with 15 plus years of teaching experience. I have mentored more than 40,000 students all over India in the GATE and PSU categories. I am qualified in GATE, UGC NET, SET, and also certified by Cisco into networking and programming. So this is quick brief about me. Okay. And guys, if you know any electrical or electronics and telecommunication engineering friends, please convey this message to them. Our experts are coming for the panel discussion of ESE Mains 2023 exam, and the dates you can see on 25th June at 9 PM for electrical engineering and on 25th June at 8 PM for electronics and telecommunication engineering. So if you know anybody from EEE and ENT, please pass this message so that they will benefit from this session. Hello GATE EASE CSE, good evening. And also guys, whoever have joined, could you please confirm my visibility and audibility, dear friends? And yes, before we start the session, let me give you very important information that our BYJU'S Exam Prep is conducting a national scholarship test. A national scholarship test. Through this test, you can avail up to 90% off on our GATE programs. The upcoming scholarship test is on 25th June 9 AM, tomorrow 9 AM. So hurry up and register for this scholarship test and get up to 90% off. Alright, now let me take you into the session. Before that, let me tell you guys, this session will be followed by a practice session. That practice session would be on our BEP, BYJU'S Exam Prep platform, not on YouTube. So if you have not downloaded our BYJU'S Exam Prep app yet, please do download. However, you can attend this practice session even from our BYJU'S Exam Prep website. So it is up to you how you wanted to attend this practice session. Okay, but guys, stay tuned. After this, we will be immediately having the practice session on our BEP app. Now, when we wanted to discuss hamming code, definitely we are supposed to discuss about this data link layer. Data link layer, which is the layer 2 of OSI or TCP IP model. It has multiple functionalities. What are those functionalities data link layer has? The first functionality we can say node to node delivery within the network and physical addressing and flow control, error control, access control, and framing. So the major functionalities of data link layer we can say as these 6 functionalities. Among these, what is today's topic? The today's topic is error control. So let me put some light on it immediately. Firstly, what is an error, dear friends? Yes, everybody please respond. What is an error? What is an error? When you say that there is an error in the data, everybody please be interactive. Please be interactive, guys. When the transmitted content and received content are not same, sender sent something, receiver received something else, then we say the data is erroneous, isn't it? So when the transmitted content is not equal to received content, then it is said to be erroneous. Not only 1 bit, Kaberi, GATE EASY CSE, yes. So not only 1 bit. So this error can be of 2 types. Single bit error, as Kaberi is telling, the data may have a change. The transmitted content, let us suppose the sent content is 1100, but 1101 is received, or 1110 is received, or 1000 is received, or 0100 is received. Okay, suppose if the transmitted content is 1100 but the received is 1101, that means there is a change in 1 bit. Here there is change in this bit 3. This is bit 2. Here there is a change in bit 1. In this way, if the transmitted and received content differ by 1 bit, that is said to be single bit error, right? And the other type of error is burst error. Burst error means more than 1 bit. That may be 2 bits or 3 bits or multiple bits. Suppose if the sent content is 1100 but receiver received 1010, that means there is a change between sent and received in 2 bits, or there is a or receiver received 1011, here there is a 3 bit difference, or 0011, there is a 4 bit difference. In this way, if more than 1 bit change is there between sent and received, that is what we call as burst error. Clear? Clear with what is single bit error, what is burst error? Alright. Now, to handle these errors, the techniques we follow are categorized into 2 types. Error detection code, error detection and correction code. What is the difference between these? Error detection code find only presence of an error, means whether error exists or not. That is what found using error detection code. But error detection and correction code find both presence as well as position of an error. Not only this code determine whether error exists or not, but also it can find where is that error, or which bit is that error, or what bits are errors. Okay, so let us see what are those error detection codes, error detection and correction codes first. So here you can see error detection codes are VRC, LRC, CRC, checksum, while detection and correction code will be Hamming code. So vertical redundancy check, longitudinal redundancy check, cyclic redundancy check and checksum are detection codes, while Hamming code is the correction code. So what is our today's topic? Hamming code. So let us put some light on this for today. Hamming code, which is a single bit detection and correction code, we are going to discuss today. The basic 8421 Hamming code, not the advanced. So today we are going to identify single bit error and also the position of it. How? So Hamming code is a detection and correction code. Means what? Using this technique you can find presence and also position. Today what we are going to discuss? Single bit error, presence and position. Okay? And before we understand what is this Hamming code technique, dear friends, please understand one very important point, that is what the sender wants to transmit. We call it as data word, let it be D. So the data to be transmitted by the sender is D. But sender can't send D alone. If D alone is sent, how the receiver know whether it has error or not? So to find out that error, check bit or redundant bits should be appended to D. So when you append means simple addition, not mathematical addition, joining. So when you append the redundant bits, that obtained content what we call as code word, let it be C. So how the code word is forming? How the code word is forming? Data word plus redundant bit. That may be one bit or multiple bits based on the technique. So the code word will be the combination or the summation of data word and redundant word. Okay. So let's see how this Hamming code works. Okay. The Hamming method uses extra parity bits to allow the identification of single bit error. How many? Not one parity bit, multiple. We will use multiple bits to identify single bit error. So what we do? First, we will write the bit positions of data word and redundant bits together starting from 1. This is a very important note you have to make. In the Hamming code, we will start numbering from 1 but not from 0. Okay. So you start writing the bit positions from 1. Okay. And then represent them in binary. Okay. Then what you have to do? Mark all the bit positions that are parse of 2 as parity bits or redundant bits. Parse of 2, that means 2 power 0, 2 power 1, 2 power 2, 2 cube, 2 raised to 4, 2 raised to 5, 2 raised to 6, etc. So the first position is a parity bit position, second bit position parity bit, third bit, fourth bit parity bit. In this way 2 power ith positions are parity bit positions. This is step 2. Step 3. The other positions are data word. So the all other bit positions are for the data to be encoded. Like 1, 2 are parity. So 3 is a data word, 4 is a parity, 5 is a data bit, 8th is the parity again. So 6, 7 would be data bit. Then again 16th bit is a parity bit. So 9, 10, 11, 12, 13, 14, 15 are data bits. In this way, identify or segregate parity bits and data bits. This is the next step. Then we have to find that parity bit value. How do you find the parity bit value? Each parity bit calculates the parity for some of the bits in the code word. Means we will use some selected positions of the data word bits. Using them, we will calculate the parity bit value. The position of the parity determine the sequence of bits that it alternatively checks and skips. Means what bit positions you have to use to calculate the parity differ from one parity bit to another parity bit. How, sir? Let's see. Guys, are you following it or not? Please give some response. Make the session interactive. And again, I am telling this session will be followed by the practice session on our BYJU'S exam prep platform. So if you have not downloaded it, download the app and be ready by opening the app. Okay. So what positions we will consider for calculating the parity? Let's see. So for the first parity bit, check one bit, skip one bit, then check one bit, skip one bit, and so on. That means alternative bit position values we will take to calculate the first parity bit. Okay, and for the second parity bit, check 2 bits, skip 2 bits, check 2 bits, skip 2 bits. That means 2, 3, suppose we have checked, skip 4, 5. Again 6, 7 you check, skip 8, 9. Again check 10, 11, skip 12, 13. Like this, you include 2, exclude 2, include 2, exclude 2. Similarly, for the next parity bit which is in the fourth position, check 4 bits, skip 4 bits, check 4, skip 4. Like 4, 5, 6, 7 you have checked, you have included, 8, 9, 10, 11 you skip. Then 12, 13, 14, 15 you include, 16, 17, 18, 19 you exclude. In this way, include 4, exclude 4, or you can say check 4, skip 4. Similarly, for position 8, means the next parity bit, fourth parity bit which is in the position 8, check 8, skip 8, include 8 bits, then exclude 8 bits. Like 8 to 15 you have included, 8, 9, 10, 11, 12, 13, 14, 15, 8 bits you include, then 16, 17, 18, 19, so on to 23 you exclude. So include 8 bits, exclude 8 bits, like this, right? Now, like this when you see, you may not understand completely. So let us apply this technique on an example. Okay, let us say the sender wants to transmit this 1101011011. Okay, so as per the Hamming code technique, what we are supposed to do, we have to write the positions from 1 and you have to identify what are the parity bit positions and what are the data bit positions. So 1 is a parity bit position, so let me write it as R1 because it is 2 power 0th position. 2 is a parity bit position, so let us write it as R2. What is the next parity bit position, dear friends? You tell me. Kaveri, Get Easy and others. What is the next parity bit position? 4. So let us write it as R4. What is the next parity bit position? 8. So let us write it as R8. Then what are the other bits? Like 3 is a data bit. So From LSB, you start filling the data bits. So 1, 1, 0, 1, 0, 1, 1, 0, 1, 0, then 1, 0, 1, 1. So whatever the values I have written, they are the data bit positions. Okay. Now, how do you calculate R1? Okay, let me change the color. Just give me a moment, I will change the color. Yep. So, how do you calculate R1 value? So, R1 include 1, exclude 1. So, alternate. That means first 3, 5, 7, 9, 11, 13. Now, what is first position? R1. So, sender exclude it, receiver include it. Okay, sender is supposed to calculate it. Now, what we are doing? I am doing XOR among them, or sometimes you may be asked to do XNOR also, means even parity, odd parity. That is based on the given question you can do. Generally, we follow even parity, means I am doing XOR among those values. So, when I do XOR between third position value 1, fifth position 1, 7th 1, 9th 0, 11th 0, 13th 1. XOR characteristic, even number of ones 0, odd number of ones 1. So, here 1, 1, 1, 1, even number, 4 ones are there. So, R1 value is 0. Now, how do you calculate R2? R2. So, R1 value is what? 0. R2. Include 2, exclude 2. So, 2, 3 you have included, 4, 5 you exclude, 6, 7 you include, 8, 9 you exclude, 10, 11 you include, 12, 13 you exclude. That's it. So, 2 is the R2. So, sender can exclude this, means skip it. So, 3 is 1, 6 is 0, 7 is 1, 10th position 1, 11th position 0. 3 ones are there. So, odd number, hence what is R2 value? 1. Go on. R4, include 4, exclude 4. So, 4, 5, 6, 7 you included, 8, 9, 10, 11 you exclude. Then 12, 13, 14, 15, but we have till 13 only. Till what you have, you can take till then. So, this would be 4 is what? R4. So, sender may ignore it. Now, 5, 1, 6, 0, 7, 1, 12, 1, 13, 1. We have 4 ones. So, 0. R4 value is 0. R8. What is R8? From 8 onwards, you have to include 8 bits. So, 8, 9, 10, 11, 12, 13, 14, 15. But 14, 15 we don't have, so we can take till 13. So, 8 is what? R4. So, sender may ignore it. The other values, if you look at 0, 1, 0, 1, 1. 3 bits we have. 3 bits we have. So, it is 1, odd number. So, R8 value 1. So, what is the data transmitted? That is what we say code word. So, what is the code word? It is 1101, 0110, 10111. Suppose this is what transmitted. Now, how receiver find the error and its position? That is what we want. That is the significance of Hamming code. Let us see. Suppose 1101 1101 0110 1011. This is what sent, but receiver received something different. See, receiver received something different. So how he will identify? Again the same. Receiver also follow the same procedure. Now receiver received code word. So he need not to assume R's, assume parities, because parities are came up in the code word itself. So receiver simply arrange the given received code word in the positions 0, 1, 1, 0, 1, 0, 1, 1, 000, 11. Now receiver also calculate his own parities. Now receiver include the positions. So for R1 dash 1, 3, 5, 7, 9, 11, 13. So what are they? 0, 1, 1, 1, 0, 0, 1. So here we have even number 0. 0 means no error. When any redundant bit you get 1, that means error. So R2 dash 2, 3, 6, 7, 10, 11. So this would be 2, 1, 1, 6, 0, 7, 1, 10, 0, 11, 11, 0. Here you have odd number. So receiver got parity as 1 means there is an error. So here error is detected. But to know the positions, receiver should calculate the other parity values also. So R3 dash 4, not R3 dash, R4 dash 4, 5, 6, 7, 12, 13. So 4 is 0, 5, 6, 7, 12, 13. So this would be 4 ones 0. Now R8 dash, from 8 onwards 8 bits, 8, 9, 10, 11, 12, 13. So they are 1, 0, 0, 0, 0, 1, 1. So this is odd number 1. So how receiver confirms that there is an error? Always the receiver says that error at R1 dash, R2 dash, R4 dash, R8 dash and so on to position. So what is R1 dash? 0, R2 dash 1, R4 dash 0, R8 dash 1. So what is this 1, 0, 1, 0? 10th position. Isn't it? So the 10th position is error. Yes or no? This 0 is error because 1101 you have sent, but 1100 receiver received. So error is identified. Error is identified. The position is also identified. So you have detected and correction is simple. So you have to make it 1. When 0 is error, make it 1. 1 is error, make it 0. So identifying the position is what the challenge here, and we did it successfully. Everybody understood how Hamming code works? And regarding Hamming code, some other important points you can say is Hamming distance. What is this Hamming distance? How many bit differences are there between one code word and other code word, like sent code word and received code word? That is called Hamming distance. And there is a rule that to detect up to D errors, the Hamming distance need to be D plus 1. And to correct up to D errors, the Hamming distance need to be 2D plus 1. So for detection, the minimum Hamming distance should be D plus 1, and to correct the minimum Hamming distance should be 2d plus 1. Okay, so please remember these points, these 2 points, because these will help to solve the questions. So guys, now the practice session we will do. Okay, let us practice on the same topic. Let us practice on the same topic, where not here. Now everybody are requested to switch to BYJU'S exam prep app. So on our BYJU'S exam prep platform, because you can see the leaderboard,